So now we have our little table filled out. Turn it on the side there so you can see it. And so now that we have the data, we can put little dots on this chart to illustrate the data. The vertical lines represent years, and the horizontal lines are the distance to the bridge. Carefully plot the data you have compiled on the graph. So here is the data from these numbers over here. And so you can turn it on its side so we can see it. And what's the next step? Connect the dots. Connect the dots. All right. So now we have a trend here. And it looks like the trend is the distance of the glacier from the bridge got further and further. In other words, the glacier was retreating up to the origin of the glacier at the top of the mountain. Something happened here in 1905, got colder, so the glacier, let's see. So the glacier grew again, and to year 2000. So we had retreat, 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 advance, retreat, advance, retreat. Something happened here from 1960 to 1978 or so. A little reversal in the trend. That's what the data shows. So question 3 on page 372 asks about times when it retreated and times when it changed direction and advanced. So those dates are given to you here in red, and they are obtained from this chart. So there's our solution to question 3B. And then going down to C, it asks about this bar. We're going to complete a bar chart and show what the temperature increasing or decreasing and get an average. So here we're talking about this chart down here. So if we compare the chart there on page 371 with our solution, or your solution, what the interest here is comparing the global information with the particular climatic record in this, as recorded by this glacier for this one glacier. And in general, there's a correspondence, right? I mean, we're going from cold to warm. Things retreating. Something was happening in here. We see the data is not consistent. It shows a little bit of a cooling trend right in these years here. And the cooling trend is also reflected in this glacial advance. Because it was cooler, the glacier got bigger and came further down the valley. So the question 1 there is about the long-term trend. Well, the long-term trend is it's getting the world is increasing by 3 degrees Fahrenheit. Well, where did we get that? Well, look over here. See, this is in 1900 and earlier. The little blue bar graph is down here, and you come over here, and it's a -1. Now you look over here, and it's a +2. So we got a +2 and a -1. How many degrees is that? Well, that's 3. That's where we get the 3. Between 1938 and 1982, there were 4 warm periods interspaced by 3 cool ones, and the warming began again in 1981. That's our solution to question 2, or C2 on page 372. And question D on page 372, describe the changes of the terminus compared to variations in average global surface temperature. Be as specific as you can. Well, the graph on slide 84 shows that the advancement of the glacier corresponded to global warming. And I have a discussion question based on all this. Do you think the glacier can be used as an indicator of climate change? Well, it's like anything else, you know, you have to take it with a grain of salt, and that one glacier is not representative of the whole world, but it does correspond to global information. And in fact, there was global cooling from 68 to 74, but the glacier retreated even though it was getting cooler. So it should have advanced. Well, why is that? Well, as Miss Weatherman pointed out to us earlier, the variety of variables involved in all this stuff about climate, and there is a bit of a lag time between the warming or cooling and the glacial response.